So we're looking to make sure that we've got our absolute value all by itself. There's nothing added to it on the outside. There's nothing multiplied on the outside. Isolate your absolute value. Well, that's already done in this case. Then check the number on the second side of the equal side. Make sure that is a positive number. Now, you only do that after you have isolated your absolute value. You then, if it's positive, you can continue further. If this number would have been negative, you would have stopped right there and said there's no solution. The next thing we do is that we know we can solve it. We have to write two equations. The first equation we write is 1/3 x minus 2 equals 5. We just remove those absolute value signs. The second equation we write is 1/3 x minus 2 equals -5. So we have to use the positive number and we have to use the negative number. And we're going to get two solutions. And my answer is going to be two solutions. Okay, solving this one. Once we solve the first one, the second one is going to solve very similarly. We're going to first bring this 2 to the other side. So we'll get the x's alone. So we have 1/3 x equals 7 plus 2, 5 plus 2, which is 7. And I'm going to put the 7 over 1 as well, because once you have the fractions, you may as well have the whole thing written in fractions. And 7 is the same as 7 over 1. Now, what we usually do when we have a fraction is we multiply by the common denominator. The common denominator is, well, I have a denominator here of 3, and here I have a denominator of 1, and 3 times 1 is 3. So my common denominator is 3. I put 3 over 1 and multiply both sides of this equation by 3 over 1. Oh, here, when we have multiplying by 3, we're going to cancel out these 3. This will leave me 1 times 1x, which is just x. And this will be 3 times 7, which is 21. So my answer for the first equation is x equals 21. Okay, I don't stop there. I go to the next equation. Again, I do the same thing. I add 2 to both sides. This gives me 1/3 x equals -5 plus 2, which is -3. Again, I'm going to put that over 1 and multiply. Once you've done the first equation, the second equation has almost the same steps in it. You're going to multiply by the common denominator, which is 3 over 1. Again, the 3 over 1 times 1/3 just gives me 1x. The 3 over 1 times -3 over 1 gives me -9. So my two answers are x equals 21 and x equals -9. And I have to give both answers. Be careful when you have a question in Delta Math that ends up having two answers. You'll see at the bottom of the Delta Math section where they're asking you to put in an answer. They're all the way on the right side. There's a little plus and a little minus sign. Plus means when you want to add additional answers. Minus is if you don't have too many answers, you want to put in less. So you'd have to press the plus sign, which would then, what it'll do, it'll open up two boxes. And then you could put one answer in one box and the second answer in the second box. Few people have asked me about this because it seems that they put in both answers. They did everything right, but they just wrote both answers in one box, and then Delta Math will mark it wrong. You have to have a different box for each answer, and you get those additional boxes by clicking on that little plus sign. You'll see it at the bottom. If you look for it, you will find it. Okay, so this was question number 15 on the practice example sheet 1. Any questions about this? Okay, so let's go on to another example. Suppose I give you this example. This is example number 17. The width of a rectangle is 5 less than the length, and the perimeter is 70. Find the dimensions of the rectangle. So remember, when we have rectangle questions, we try to draw a little picture. This is our width. This is our length. They said the width is 5 lengths less than the length. That means the W is L minus 5. 5 less means you have to subtract 5 from the length. This side will also be L minus 5, and this side will also be L. The opposite sides of a rectangle are equal. We're told that the perimeter is 70, which means that when we add all 4 sides, L minus 5 plus L minus 5 plus L, that's going to add up to be 70. Collecting the like terms, I get 4L minus 10 equals 70. Adding 10 to both sides, we get 4L equals 80. Divide by 4, and we get L equals 20. The length of this rectangle is 20. Now remember, the width is L minus 5. In other words, it's 20 minus 5, or 15. We figure this out by doing 20 minus 5. And now I know that the length is 20 and the width is 15. You could also have written your answer like this: 20 times 15. This time sign is read by. It's 20 by 15. That is, you can write the dimensions that way as well. You can either write them separately, length is this, width is this, or you can write it in this fashion. But dimensions means both the length and the width. Does anybody have any questions on anything that we did in chapter 1 before I go on? Okay, great. So I'm going to erase this, and I'm going to start with the material on chapter 2. And I'll get started on that, and then a little bit later I'll take attendance. Well, I'll give you some problem to work on. The topic of chapter 2 is what's called linear equations. And what we're going to be doing in this chapter is looking at how do we graph linear equations. How do we go from an equation, which is something that has x's and y's and etc. numbers, to a graph, which is a picture. And that's the whole point of something that's called Cartesian coordinate graphing. the type of graphing that you've learned in school previous to this, and that we've done before, or you've done in other classes, I should say, is something that's where you have two axes, a horizontal axis, that's one that goes side to side, which is called the x-axis, and a vertical axis, which is called the y-axis, and they meet at a point which we call the origin. The actual originator of this type of graphing was somebody called René Descartes. That's why this is called Cartesian coordinate graphing. Not important for you to know that, but he was a French mathematician, and he lived, I guess, in the 1700s. And actually, without that type of graphing that connects algebra to geometry, numbers to pictures, we would not have been able to do any of the things that we do today with graphing, including higher mathematics like pre-calculus and calculus, etc. Very much depend on this type of graphing. Okay, you don't have to know what it's called, but it's just a little bit of interesting historical background. Okay, what do we do in Cartesian coordinate graphing? Every point on the plane, every point on this flat surface is connected to a pair of numbers. For example, if I write something like this, -3, -1, and I put it in parentheses, this is called an ordered pair of numbers, and it represents a point. What do you mean it represents a point? It's numbers. How can it represent a point? Because it tells you the location of a point on the graph. If I say go to the point -3, -1, that means the first number is always the x number. -3 means go 3 to the left. And the second number is always the up and down number, the y number. It goes -1 on that. And here is your point, -3, -1. I know this is not new for you. You've probably done this many times before. Any point on the graph has a pair of numbers called an ordered pair of numbers. It's called an ordered pair of numbers because the first number always is the side-to-side number. The second number is always the up and down number. It's in that particular order. If I were to go to this point, say I went to, here's a point. I can tell you what the coordinates of that point are, the coordinates being the numbers. I know to get to this point, I have to go 1 to the left. So my x coordinate is -1. And then I have to go 1, 2, 3, 4 up. So my y coordinate is 4. And we say this is the point -1, 4. Now, you know, -1, 4 is not a point, it's numbers. But the point that we're talking about is this point on the graph that you get to by going to -1, 4. The origin coordinates are 0, 0. Because if you're at the origin, you're not going left to right or up or down. Any point on the x-axis, let's say I have this point here, 1, 2, 3, 4, 5. Any point that's on the x-axis has a y coordinate of 0. Because when you're on the x-axis, you're not going up or down. Any point on the y-axis, for example, this point, has an x coordinate of 0, because you're not going left or right. This is a point 0, -5. What we sometimes say is that the x coordinate, the x intercept here is 5. The x-intercept meaning the point on the x-axis. So these are how we graph points on a piece of graph paper using the Cartesian coordinate method. Okay? I think most people know how to deal with the points. What we're going to concentrate on today is how do we graph equations, specifically linear equations, when we have, how do we graph them on our graph paper, on our Cartesian coordinate system. I'm going to erase this so I can start something new. Okay, here's my piece of graph paper. I know you're imagining this as a piece of graph paper. It doesn't look too much like a piece of graph paper, but that's what it is. I'm going to show you two methods that can be used to graph a linear equation. Now, what is a linear equation going to look like, and what does it mean that it's a linear equation? Well, here's one example of a linear equation. Suppose I gave you 3x minus 2y equals 6. Notice the equation has two variables. It has an x and a y. Most of the equations that we'll graph on a piece of graph paper will have two variables. Every so often we will have an equation that only has one variable, only just an x or only just a y, and we'll discuss what that means when we get to that. This type of equation is called linear or first degree. Because the highest exponent you're going to see in this equation is 1. Remember, if no exponent is shown, it means its exponent is 1. There isn't ever going to be an x squared. There's not going to be the square root of x. There's not going to be an x to the third. The highest exponent in a linear equation is always 1. That's why it's also called a first degree equation, because the degree of an equation is the highest exponent that you see. First degree means my highest exponent is going to be 1. It turns out every time you have an equation that's a first degree equation, it will graphically turn out to be a line. That's why we call first degree equations linear equations, from the word line. Even when we're talking about it, not in terms of the context of what it looks like, we still call it a linear equation. All it means is you don't have any exponents on your variables. Now, how can I draw the picture of the line that this represents? So what we have to do is one of two methods. One method is called the intercept method. Let's call this method number 1. The intercepts of a line, the word intercepts means cross, is where does a line cross the x and the y axis. If you know the intercepts of the line, remember, let's say here's one intercept, here's another, then you just connect it and there you have your line. You only need 2 points to find a line. How do we find the intercepts? Well, if I want to find the x-intercept, in other words, where the line is going to cross the x-axis, I know that if it's going to be on the x-axis, the y value has to be equal to 0. So I take my equation and I replace the y with 0. Notice when I do that, I'll get 3x minus 2 times 0 equals 6. 2 times 0 is 0, so this is just 3x minus 0, which is 3x equals 6. And when I divide by 3, I get x equals 2. The x-intercept is 2. Now that's really, what we really should say is the x-intercept is 2, 0. I sometimes just say the x-intercept is 2 because an x-intercept has to have the y equal to 0, but the correct way to write the x-intercept is 2, 0. On my graph, here's the 2, 0. 2 to the right, 0 on the y, which means it's right on the x-axis. How do we find the y-intercept? Well, if you think about it, in order for it to be on the y-axis, the x has to be equal to 0. So take your equation, your 3x minus 2y equals 6, and replace your x now with 0. So what will you get in that case? You'll get 3 times 0, which is 0, minus 2y equals 6. And if I solve that, I will get y equals 6 divided by negative 2, which is negative 3. My y-intercept is the point x0, y, negative 3. Here it is, x0, 1, 2, 3. Now notice I have these 2 points. I can now draw my line by connecting the 2 points. And I even go beyond either point because a line extends in either direction. And therefore, here is my line. I find it by doing the finding. I did found this line. I graphed this line by putting it, by finding it's both its x and y intercepts. Any question about this? Okay, so I'm going to do this exact problem again, alternate method. It's an alternate method. You can do either method you prefer. If you're asked to graph a line, you can use this intercept method, or you can use something called the slope-intercept method. Okay, so now we're going to redo the same problem. You'll see we'll get the same exact line using the slope-intercept method. The way I presented this equation to you is what we call the standard form of the equation. If you notice, I have an x, then I have a y, my equal sign, and a number. That is what's the standard form of a linear equation. Again, remember, it's linear because there are no exponents. There is another format of the equation of a line, which is called the slope-intercept form, which is written as y equals mx plus b. And if you have the equation given in the slope-intercept form, then you can use what's called the slope and the y-intercept to graph the line, and that's what I'm going to show you right now. In order to put something into the slope-intercept form, what you have to do is solve for y. You have to get the y by itself. So in order to get the y by itself, the first thing I have to do is subtract the 3x from both sides. So that'll give me negative 2y. Now here I have two terms. I have a 6 and a negative 3x, and they're not like terms. So therefore I have to keep them separate. To put it in the right format, I'm going to put the x term first, the negative 3x, and the number second. There's nothing wrong with writing this as 6 minus 3x, but the correct format is to put the x first and the number second, the number that doesn't have any x, so it'll be in this y equals mx plus b form. I then have to divide by the coefficient of the y, so I'm going to divide everything by negative 2. And that'll give me y equals, well, now I have a negative 3 divided by negative 2. A negative over negative is positive, so it's 3 over 2x. And 6 divided by negative 2 is minus 3. I have taken this original equation that was in standard form and put it into the slope-intercept form. And now I can see that the slope of this line, this is what we call the m, is the number in front of the x, the coefficient of the x, which is 3 over 2. And the b, which is what the y-intercept, is the standalone number, which is negative 3. Using these two pieces of information, I can draw my line. Here's my piece of graph paper. Here's my x-axis, here's my y-axis. When I'm using the slope-intercept form to graph a line, my first place I go to is the y-intercept. The b is negative 3. That means this line is crossing the y-axis at negative 3. Notice I didn't have to do anything to figure out the y-intercept. Once it's in the y-intercept, in the y equals mx plus b form, you get the y-intercept for free. It happens to be negative 3. Okay, but it's not enough to have just one line, 1 point, I'm sorry. You can't have 1 point because the line could go any which way through that point. That's where your slope is going to help you. Now, what does the word slope mean? Probably the most common place you've seen the word slope is, say somebody goes skiing and they say, oh, I went down the slope of the hill or the slope of the mountain. And obviously what it means is the slant of the slope has to do with how much the mountain or the hill is slanted. The same thing with the slope of a line. It's what tells us how much the line is slanted. And somebody put on the chat, it means rise over run. So what the slope tells you is how to get from one point on the graph to another point on the graph. Let's say my slope is 3 over 2. The first point I know on this graph is the y-intercept of negative 3. Starting at that point, I'm going to use the slope to get to another point. I'm going to rise 3, so that means go up 3. And I'm going to run 2. Run means go to the right. 1, 2. That will get me to a second point. It's enough to draw it, but if you want to do more points, you could do it again. You can now start from this second point and again rise 3, run 2. Gives you a third point. Equivalently, 3 over 2 would be the same as negative 3 over negative 2. A negative over a negative would be positive. So therefore, I could have risen negative 3, which means go down 3. A negative rise means go down. And run negative 2, which means instead of going to the right, now go to the left 2. And notice how that also all lines up. And notice if you look at the picture of the first line and the picture of this line, you're getting the exact same line. This is what's called the slope-intercept method. The other method was the method of the intercept method. Which method you use depends on whichever you like better. I happen to like this method better, but you can like the other method better, and we could do it by that other method. Notice when you put the line, the equation of the line in the y equals mx plus b form, you will automatically know what the slope of the line is, and you'll know automatically what the y-intercept is by just manipulating the equation of the line. Okay, I want to do 2 special lines, and then I'll give you a problem to try while I take attendance. Okay, what are the 2 special types of lines that I would like to talk about? Those are the lines that are not slanted. What type of lines are not slanted? Well, either lines that go straight up and down, or lines that go straight across. In other words, we can have horizontal lines. Let's see, here's my x-axis, here's my y-axis. Let's say I have this line. Here is a horizontal line. And lines that go straight up and down are called vertical lines. This is horizontal. You look at the horizon, it's straight across. That's why it's called horizontal. If I look at some of the points that would be on this line, obviously this is the point 0, 2, because it's where it's on the y-axis. So the x is 0, the y is 2. If I look at this point, this is the point 2 to the right and 2 up. I mean 2 to the left, negative 2, 2. What about this point over here? Notice I've gone 3 to the right, so my x is 3, and I've gone 2 up. So this is the point 3, 2. And if you notice, the one thing that all the points on the line have are that the y values are 2. And actually, y equals 2 is the equation of this line. When you have a horizontal line, all the y values are going to be the same number. The x numbers can be anything at all. So when we write our equation, we only include the y because that's what we know about. Y equals 2. In a line that is horizontal, that equation is only with y's. It has no x's in that equation. And if you ask what is the slope, if you think about what is rise over run, well, let's say I go from here to here. Am I rising at all? I'm rising 0. I'm running 3. Well, 0 over anything is 0. The slope of a horizontal line is always equal to 0. If I were to draw this line, 1, 2, 3, this horizontal line, and I asked you what is the equation of that line, well, here it would be y equals negative 3, because the y value on all of these points is negative 3. So, and if I were to give you this equation, y equals 1, you would know that's this horizontal line right here. So horizontal lines are really easy to deal with. It's just an equation, y equals a number. And whatever that number is, you go to the y-axis and just go across at that point. This would be, and the x-axis itself would be y equals 0, because at that point the y is 0. So horizontal lines, y equals a number, the slope is equal to 0. Let's talk about vertical lines, because that's the other special type of line. Suppose I have, here's my graph again. Suppose I have this line, a vertical line, a line that goes straight up and down. But let's look at some of the points on this vertical line. Well, this is certainly the point 2, 0, because that's on the x-axis. What about this point? Well, that's a point 2, 2. What about this point? 1, 2, 3. That's 2 to the right, -3. If you notice on your vertical line, all the x values are the same. In this case, all the x values are equal to 2. The equation of a vertical line is x equal to a number. In this case, it's x equals 2. The y values could be all different numbers, but the x values all have to be 2 in order for it to be on this vertical line. If I were to say, I want you to draw the line x equals -3, then all you'd have to do is go 3 to the left and draw the vertical line. Here's your line, x equals -3. Again, a line that has only, an equation that has only an x with no y's in it means it's a vertical line, and it'll go through the -3 on the x. What about the slope of this line, type of line? Again, remember, slope means rise over run. So let's go, let's say, from this point to this point. Well, obviously, we're rising 2, we're going up 2. But how much are we going left or right? We're not going left or right at all. The run is always 0 because we're neither going left nor right. Well, any number over 0 is not a real number. In other words, the slope, we can say, does not exist, DNE. Or sometimes say undefined, means the same thing. A vertical line is the only type of line that does not have a slope, because you cannot have remember, the slope is a fraction, and you cannot deal with a fraction as a 0 in the denominator. That's not a valid number. So vertical lines have equations x equal to a number. They do not have a slope, or their slope is undefined. There's no such number. It's not 0. It doesn't exist. Okay, so those are so far what we've covered. When I take attendance, I'm going to put 2 problems on the board. I'm not going to go on into breakout rooms now, but I'm going to and I'll let you use them, and then we'll do those 2 problems after I take attendance. So here are the 2 questions I want you to do. Number 1, I want you to graph the line whose equation is 4x minus 2y equals, let's make it, let's do that. That'll be your first question. Your second question is going to be, what is the equation? Write the equation of the law of the vertical line through the point -1, -4. Okay. I want you to do the work on these two problems while I am taking attendance. Remember, if you have the ability to open up your video and show your face when I call your name, that would be helpful. I'm going to turn off the recording while I'm taking attendance. Somebody, I better remember to turn it. You're gonna be my mentor. You're gonna tell me what to do when I forget.
Okay.
I need it. If you think this is new for you, it's new for me also. Okay, should we do it by the intercept method? I see somebody answered, so let's see what they answered. Anybody have a suggestion? Y equals mx method, or in other words, slope intercept method or intercept method? We have our choice. We could do it either way. Which one would you prefer?
Intercept.
Intercept? Okay, let's do it.
Intercept.
Okay, I think most people like intercepts when it's set up like this. It's when we have it in what's called the standard format. Now I'm just going to erase, I'm going to put this on the side, -1, -4. I want the vertical line. Keep that in mind, so I just need my board space. Okay. We are going to do this first by finding the x-intercept, then we'll find the y-intercept, and then we'll connect those 2 points. Remembering that when we do the x-intercept, we set the y equal to 0. That, leaving the y equal to 0, that just gets rid of the y, so I'm left with 4x equaling 8. And when I divide by 4, that gives me x equal to 2. My x-intercept is 2. The better way to write it is the x-intercept is the point 2, 0. When you have an x-intercept, the y value is always 0. So the x-intercept is 2, 0. Here it is on my graph. 1, 2. Here's my x-intercept at 2. Okay, now let's find the y-intercept. To find the y-intercept, we have to let the x equal to 0. So in this equation, this is going to drop out, and I'll be left with -2y, because the x part is 0, equals 8. When I divide by -2, it gives me y equals 8 divided by -2, which is -4. That means my y-intercept is x is 0, y is -4. Let's see where that point will be. That means go 4 down on the y-axis. And here are my 2 points, and I'm connecting them. And there is my graph. And here's the line. I hope everybody got a line that looked essentially like this. I want to make a comment about the slope of this line. Okay. Once I have a line on a graph, I can really figure out what its slope is by sort of doing what we call count boxes. Remember, the slope is rise over run. So if I have a picture of a line, I can actually figure out what the slope is by doing literally rise over run. Start with a point that's on the left and work your way to the point that's on the right. How do I go from this point to this point? Well, the rise is going to be 1, 2, 3, 4 up. So my rise is 4. And my run is 1, 2. So the slope would be 4 over 2, which we could have reduced to 2 over 1 or just 2. The slope of this line is 2. I could have gotten it by just looking at the line and doing rise over run. Remember, if as you're going from left to right, your line is going down, your rise would be a negative rise because you'd be going down and then to the right. Again, rise over run, up or down, to the right. Is there any question about that? I'm going to show you, let me just see what's on the chat. I'm going to show you how I could have actually found the slope of the line by looking at the equation. So I'm going to erase this piece. And look at my equation, 4x minus 2y equals 8. If I had asked you what is the slope of this line, I didn't ask you to graph it, I just asked you what the slope is. I could have done it this way by drawing the graph, but I could have also done it by putting the equation in the slope-intercept form. In other words, solving for y. I would have first have to subtract 4x from both sides. Remember, we did this before, type of thing. That'll leave me negative 2y equals negative 4x plus 8. And now I have to divide everything by negative 2. In other words, I'm solving for y. This gives me y equals, well, negative 4 divided by negative 2 is 2. And 8 divided by negative 2 is negative 4. So my equation in slope-intercept form, in what we call the y equals mx plus b form, is y equals 2x minus 4. If I compare it, the number in front of it, the x, is the m. The coefficient of the x is 2. The slope is 2. Now, usually we write the slope as a fraction, so any whole number would be 2 over 1. Because if we want to do it as rise over run, it would be rise 2, run 1. Notice if I rise 2, run 1, I get over here, and if I rise 2 and run 1, I get over here. So that is the slope. The slope we get by looking at the coefficient of the x. The b is the y-intercept. That's the standalone number. which is -4. In other words, the y-intercept is x is 0, y is -4. But we could just say the y-intercept is -4. In other words, if you have your line in the y equals mx plus b form, you right away can tell what the slope of that line is and what the y-intercept is. So that I happen to like this slope-intercept form because it gives me so much information by putting it in that format. Okay, let's do this problem and then we'll talk some more about slope. I wanted you to write the equation of the vertical line that's through the point -1, -4. So I'm going to draw a picture of this. Here's my point -1, -4. 1 to the left, 4 down. And a vertical line is one that goes straight up and down. So here's my vertical line. What is the equation of this line? Here's my x-axis and here's my y, by the way. Remembering that any vertical line has an equation x equals a number. All I have to do is look, what are the x numbers over here? Obviously, it's a -1. The equation of this vertical line is x equals -1. If I had asked for the horizontal line, the equation would have been y equals -4. So I could have right away seen, since it has to be x equal, I just look what the x is, and that's x equal -1. Don't say -1 is the equation. An equation has to have an x or a y or both, and it has to have an equal sign. So it's x equals -1. By the way, the vertical line has, if I asked you what's the slope, you would tell me it doesn't exist. It's undefined. There's no such thing as a slope of a vertical line. So that takes care of that problem. All right, did anybody have any question about either of these problems before I go on? Okay, so I want to talk a little bit more about the slope of the line. Let me give you 2 points. Let's say I give you the point 2, -3, and the point -1, 2. 2 points. Obviously, if you have 2 points, you should be able to draw the line. I want to draw this line, and then I want to find the slope of the line. We're going to next time learn not only to write this, find the slope of the line, but we'll learn how to write the equation of the line. But now we're just going to write the slope of the line. Okay, so let's get a picture of it over here, though you don't have to draw it. 2 -3 would be 2 to the right, 3 down. -1, 2 would be 1 to the left, 2 up. And if I join these 2 points, here's my line. Here's the line I'm talking about. Notice I go further than either because the line extends in either direction. I am interested in finding the slope of this line. Now notice as I'm going from left to right, which is always how I describe the slope, I am going down. Anytime the line goes down as you go from left to right, your slope is going to be negative. It's a falling line. If as you go from left to right, you're going up, your slope is positive. It's a rising line. How am I going to find the slope of the line? Now, if this was on a piece of graph paper and I had a lot of lines and it would be easy to count boxes, I could use that to find the slope. But this is not quite so easy to count boxes. I don't see any boxes. So to find the slope, I'm going to use something called the slope formula. The slope formula looks like this. M equals y2 minus y1 over x2 minus x1. You don't even have to draw the picture. You can just apply the formula and it will give you the slope of the line. It's the difference of the y's over the difference of the x's. What does that mean? We pick one point to be our first point, usually the one that's on the left, and call that your x1, y1. X sub 1 meaning the x of the first point. Y1, the y of the first point. It doesn't have anything to do with exponents. It's just telling you the difference between the 2 points. Your second point, usually the one that's on the right, we call the x2, y2. The x of the second point, the y of the second point. And now you just substitute it into the formula. Y2, which is negative 3, minus y1, which is 2. So the numerator is negative 3 minus 2 over x2, which is 2. Notice I've written it above it so it's easy to find it. Minus x1, so it's minus negative 1. So on the top, we're going to get negative 3 minus 2, which is negative 5. And 2 minus negative 1, that 2 negatives makes a positive, is 3. The slope of this line is negative 5 over 3. What does that mean? That if I started at this point, I would rise negative 5, which means I'd go down 5, 1, 2, 3, 4, 5. And then I'd go 3 to the right. I'd run 3, 1, 2, 3. And that would give me another point. Notice I could have also looked at this as 5 over negative 3. The negative, it doesn't matter if it's on the top or the bottom. And that positive divided by negative is going to always be negative. That means I could have started here and risen 5, 1, 2, 3, 4, 5, and then run negative 3, which means go 3 to the left, 1, 2, 3. Notice if I did that, I would get to another point on this line. So what the slope of, once you have one point, you can get dozens of points on your line by just going from one point to the next point using the slope, and then going from that next point to a third point or fourth point using the slope. Again, when it comes to a negative, the negative could be in the numerator, which means you're going down and then to the right positive. Or if you put the negative in the denominator, that means you go up and then to the left. Notice a negative slope gives you a line that is going down. All right. Does anybody have any questions of what we've done so far? What you should be able to do at this point is, given an equation of a line, you should be able to graph the line, and you should be able to find the slope of the line From the equation number 1, if I gave you equation, you should be able to figure out what the m is. And also, if I give you 2 points, you should be able to find the slope. Our next stage after this, that's what I'm gonna start on Tuesday, is going to be what happens, first of all, the significance of the slope. It tells us something about the lines. We're going to talk about parallel and perpendicular lines, number 1. And we're also going to see that we can write the equation of a line. If I describe a line to you, you'll be able to not only draw a picture of it, but you'll be able to write the equation. We're going to figure out how to write the equation of this line and other lines. That's going to be our next project. I'm going to give you another problem to try in class. Remember that today we're not doing the breakout rooms, but if you want to be in a particular breakout room, let me know who you want to be with so that I can arrange those breakout rooms for you. Here's your homework, aside from the delta math, which you have to look up. See what's on delta math and when it's due. Your homework on practice example sheet 2. Our examples 1 through 9. That's what we'll be covering on Tuesday. I'm going to let you get started on these. If you don't have your, I'll write the examples on the board.
How do we turn in the homework? How will we turn it in? Email to
you?
you?
This homework does not have to be turned in.
Okay.
You only have to do the actual homework that you get marked on as a homework mark is the delta math.
Okay.
For you to do, and we do it in class. Again, the point is, I did send you the answer key. If you're not getting them right, these are the questions that you have to know how to do. Okay, so I'm going to put the first problem on the board, and I'm going to be here. And if anybody wants to consult with me, I am sitting here. I want you to do. It says, write a slope, this is number 1, intercept equation. I'll call you back in a couple minutes. A slope-intercept equation for this line. They're giving us 3x minus 5y equals 15. I want you to write it in the slope-intercept format, and then I'd like you to tell me what is the slope and what is the y-intercept. This is question number 1 on practice sheet 2. Okay? If anybody has any questions how to do this, you can ask me. I'm going to stop the recording now because this is homework.